And this is a roll of 36 exposure. Oh, hi. I was just dropping off a roll of film to be developed. Have you ever wondered how photographs go from this to these? Well, we got a letter here from Leonard Bailey in Trumansburg, New York. And he wrote us wanting to know what happens to a piece of film to make a picture. It's a good question. You know, I'll bet we could find that out right here. Do you suppose it would be possible to show me how a photograph gets developed in the back room here?
Sure, come on back. I'll have you talk to Steve.
Great. I was hoping you could explain to me how you actually develop film back here.
Sure, I'd be happy to, David. The film is removed from the film canister and put through a film processor, and this gives us our negative. Then the negative is exposed onto the photographic paper at this machine. A light shines through the negative, through a lens, and onto the photographic paper. And the photographic paper then advances into the paper processor, and it goes through a series of chemical steps and a dryer and a cutter, and comes out a finished print on the other end.
Where does the color in my photograph come from?
Both photographic film and paper have light-sensitive dye layers. There's a red, a green, and a blue-sensitive layer, and the colors that you see in your print come from that.
So what is going on chemically inside this machine that develops the photograph?
Well, for that, David, you'd have to go into an actual darkroom.
And that's where I found Dave Robson, editor of Chem Matters magazine. And it's not really dark. There's a light that's filtered so it won't affect the film.
I'd like you to put these goggles on.
All right, now we're doing something dangerous here?
No, but I always like to protect your eyes. All right, I've been using a negative like this one to make the enlargement.
What actually is a negative, Dave?
Well, this was the piece of film that was originally in the camera that's been developed.
So how do you get from this stage to an actual photograph?
Okay, well, that goes in the enlarger. We project light through it to make an image on this sheet of light-sensitive paper. Now, I've finished the exposure. If you would see that image?
I don't see anything.
Or if you would put that in the developer, you will. Okay, step over here to the sink. I'd like you to slide that into the first tray, which contains developer.
Put the paper right in the liquid?
Get it wet, slide it right in there, and once it's in, rock the tray gently to move the liquid around. That's right. And very shortly, you'll see a picture. I think you'll recognize it.
Oh, here it comes. Look at that. Oh, it's Peggy. Look, in the forest or in the redwoods or something. That's a big tree.
Nice picture, right?
Great. It's like magic. I mean, the photo just appears on the paper out of
really
nowhere.
Exciting.
How's that work?
Well, to really understand that, you'll have to take a close-up look at a piece of film. David, this represents a piece of film in your camera.
And what are these little dots here?
Those are crystals of silver bromide, and surrounding them, the gray area is gelatin.
And when you say gelatin, is that like the gelatin we eat gelatin?
It's exactly like that.
No kidding, on film?
It serves here to stick the silver bromide to the clear film behind it.
Wow. Now, what's so special about silver bromide?
Well, it's
particles?
extremely light sensitive, and I can show you that. I'd like you to make a chemical cousin to silver bromide. Come on over here. We're going to make some silver chloride. I've got some solutions prepared for you. What I'd like you to do is pour these into this beaker. As soon as you get a new chemical, immediately pour it onto that paper towel.
How am I going to know if I have a new chemical or not?
I think you'll get the idea. Okay,
Mix
pour them
the two
in
together?
there. There you go. Okay.
No, I have it immediately.
Whoa. Okay, now quick.
Time
Pour
is
it onto
everything
that
in
paper
photography,
towel. That's right? And spread it as you pour. The liquid is going to drain away. All right, now use the spoon to spread out some of the clumps, and we want to get into the edges here. And
what did I make here again?
You are making light-sensitive paper. Here's what I'd like you to do. That's fine. That's fine. Now, put your hand down there.
Just put it right in the
We're going to turn on a bright light. Okay, let's have the light. Okay. And what will happen, this will take about 20 or 30 seconds, but there'll be a change in those crystals.
Oh, wow, look at this. It made an image of my hand.
Let's see. Isn't that lovely?
That's great. Now, how did it do that?
Okay, here's what's happening.
Can I take these gloves off?
Please take them off. Take a look at this model of a silver chloride crystal, all right? This represents a silver particle, chloride particle, silver particle. That continues for millions of particles, right?
Okay.
Now, when the light hit it, some of these silvers changed from a charged condition to a neutral condition and made silver metal, just like in a coin.
Wow, so when the light strikes these clusters of atoms, basically,
crystals,
it converts all of those silver particles to solid silver.
Solid silver metal, that's right. And that's why we saw all the dark gradually emerge over here, because silver in little pieces looks dark.
So wait a minute, why did this all turn black?
Well, the same phenomenon that made a little of it turn black turned the rest of it black, and that's the second part of developing it.
That's what happens on our film, then?
Well, not in the photographic film you're using your camera, because we can't expose that for 30 seconds. Right?
That's true. That's a very quick shutter speed.
That's right. And that's where the other magic of silver comes in. In your camera, you only need to convert 4 of these, not billions, just 4. and those sort of mark the crystal as exposed and make it easier to change later in chemical development. Photographers call that a latent image.
Now, in a regular piece of film, what does this development process look like?
Well, I'll tell you what. To understand it, I think you should experience it personally. We're going to make you into a piece of film. There it is.
The latest in film fashion. Huh?
Polka dots and all.
What is with the polka dots anyway?
Okay, well, the polka dots represent the light-sensitive crystals of silver bromide.
Oh, that we had in that original
That's
piece
right.
of film. So am I all ready to be developed?
Well, you haven't been exposed to an image yet, so we have to do that first. Step on back
You're
here.
gonna expose me.
I'm going to expose
Here
you
on national television, a first for
Why
Newton's
not?
Apple.
Okay. Now pretend that you're in the back of the camera. Here's the camera's lens, and we're going to throw an image right onto the film.
What's the
Bingo.
image?
Looks like.
Oh, the letter N. I can see that.
How about for Newton's Apple?
Better
Note
stand
that that's
still.
a white N.
That's
Okay.
important to remember,
Exposure's
huh?
finished. All right.
Okay.
Now take a look
Oh, wait
at the
a minute.
image.
What happened to the N?
Remember, this is a latent image. We've only seeded those crystals. We have not exposed them long enough to really develop.
So it's just sort of in the memory of the film.
That's
right
correct. Now, to get that full image, we need to develop, and into the developer you go.
And
Okay?
you mean this literally, don't you?
Literally do.
Into
okay.
the development pool.
All right. So we go to chemical treatment called developer, and that will alter. Come on, get
You gotta
in
lay
there.
right down in it, don't
You
you?
have to do it sooner
Dip
or
the
later.
film
Go for it. Take the
in.
plunge. Okay. Now, the key to good development is to agitate. Ready?
Swim in the developer.
Okay. All right. Now, while
What do you
you're
think?
in
Think I'm
there,
done?
while you are in there, the chemical is changing the remainder of the crystals that have been exposed, bringing out the silver, making it into silver metal, and the ones that have not been exposed are not being changed. Come on, let's see how it's going. Let's see. Yep.
Let's see what we got here.
Excellent. There
Hey,
it
look
is.
at that, the letter N.
The letter N. You
Now,
okay?
is it all
We
done?
developed it? Well, it's not all finished because if we stop here, do you remember that image we made of your hand, of the silhouette?
Oh, it turned
Remember what
black
happened?
after a while. The whole
Absolutely.
thing did.
Yeah, and that would happen here. These other crystals would eventually turn black, and you'd have all black. Image would be gone.
So how are we going to prevent that?
Step over here, and I'll show you exactly what photographers do. They use a solution called Fixer.
Aha.
And what this will do, well, let me show you just here a moment. Ready? This will,
Fix me, huh?
look at that. It's going to dissolve the crystals which have not been exposed and not been developed. Once they're gone, they can't turn black, and the image will be
So
permanent.
the only thing we'll have left is just the letter N. At
The
this
letter
point.
N. Okay. Works remarkably well. Okay, now,
All right.
There.
Voila.
voila, there it is.
So, Dave, if I just drip dye here for a moment, am I ready for the photo album?
Well, that is a permanent image, but it's not a positive that you would put in a picture album. That's a negative. Remember the N that I
forgot about
projected
the
on you?
negative
The
process.
N was white, now it's black.
So we're like only halfway done here, aren't
We
we?
have to go back to the dark room. But first, I'm going to take your snapshot.
Okay.
Ready? And there it is.
Picture of me in the warehouse wearing my letter N, huh?
That's right. Now, you experienced the process of being made into a negative. Now, when I took the picture of you, I processed the negative, and from that negative made this print.
What's the difference, Dave, between this paper and the film that's in the camera that you develop into a negative?
Well, not as much as you might think. As far as light-sensitive crystals and gelatin, it's all the same. It's simply spread on paper instead of on clear plastic.
And then is the developing process
The
the same?
chemistry is the same, very similar.
Thanks so much, Dave. This has been great chemistry. We'll have more in just a minute.